students, today we are going to do chapter 14 statistic, and the topic of this chapter which we will discuss today is mode of group data. In our previous session, we discussed about the type of presentation of data in different tabular forms, and we also discussed what is the meaning of arithmetic mean. We calculated arithmetic mean using three different methods. First was direct method, then shortcut or assumed mean method, and the third method was step deviation method. To understand mode, let me take first raw data of 11 students scoring marks in a test. I have represented it through xi. To find out mode of this representation, what I will do? I will arrange these values in ascending order. This gives me an idea that there are 3 students scoring 17 marks, which is the maximum number of students scoring same marks. Therefore, for this distribution, this data, mode is 17 because these are the marks scored by maximum number of students. We can also say these are the marks having maximum frequency. Let us see the distribution where we have frequencies also. So, in this case, we have discrete frequency distribution table. Let us see in such cases what do we mean by mode. In this table, there is a company who wants to manufacture trousers for the people of age group 14 years to 20 years. They wanted to know what will be the proper waist size, the maximum most prevalent waist size for such age group. They did a survey for 150 on 150 people of the same age group 14 years to 20 years. Out of these 150 people, they found 19 have waist size 24 inches. 17 people had waist size 26 inches, and the maximum number of people, that is 43, had waist size 28 inches. As you can see, this is the maximum frequency, that is 43. So, the company decided that 28 inches is the most prevalent size of waist for this age group of people. So, this is actually the mode. 28 inches turns out to be our mode because it has maximum frequency. Let me change these frequencies a bit. If the factory would have got these frequencies for different waist sizes, then what can be observed from this? You can see that maximum number of people, that is 43, are having two sizes, 28 inches and 30 inches. So, here in this distribution, we have two modes. Such type of data is called bimodal. Now, you must have understood what is the meaning of mode. Mode of a distribution is that value of variable for which the frequency is maximum. We can also say value of the variable around which values of variable are clustered densely. Let us take a question from exercise 14.2. In this question, in the table, we are given ages of patients admitted in the hospital during a year. You can see in the first class interval 5 to 15, there are 6 patients admitted in the hospital during that particular year. Let us understand this class interval. 5 to 15. In this interval, 5 years is included but 15 years is excluded. That means if a patient of age 15 years is admitted in the hospital, that patient will be marked in second class interval and not in the first one. Any patient having age 25 years will be considered in the third class interval and not in the second. So, the upper class limit of the class interval is not included in that interval. We are asked in this question to find out mode as well as mean. Then we have to interpret these two measures of central tendency. That is, what does these values of mode and mean mean in this case? Let us calculate mode first. So, you can see in our table, we will first find out where lies the maximum frequency. We can see out of these frequencies, 23 is the highest maximum frequency. This will be termed as F1. The class interval having maximum frequency will be termed as model class. So, our model class is 35 to 45 having frequency 23 and 23 is termed as F1. To calculate mode of this data, we are going to use the formula mode is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Let us see what these symbols stand for. You can see that our class interval 35 to 45 is our model class. So, the lower limit of this model class will be the value of L. So, L represents actually the lower limit of model class. Here F1, as I said before, is the maximum frequency, that is frequency of model class. H is class size, that is upper limit minus lower limit. So, it will be 45 minus 35, that is 10. Frequency of the class preceding to model class will be termed as F0. So, you can see that the frequency of class preceding to model class is 21, which we are going to use as F0. The frequency of the class succeeding the model class is termed as F2, which in this case is 14. After taking these values, we are going to substitute them in this formula. So, mode will turn out to be, in place of L we will put 35, F1 was 23, F0 was 21, 2 into F1 was 23, F0 21 and F2 14. And remember, our class size was 10, which was H. When we calculate this expression, we first multiply 2 and 23 and get the answer as 46. Then when we add these two values, that is minus 21 and minus 14, we get minus 35. Solving these two numbers, 46 minus 35 gives us 11. So, when we do the final calculation, we get the answer as 35 plus 20 upon 11. 20 upon 11 when converted in terms of decimal, we get 1.8. Adding 35 and 1.8, the answer turns out to be 36.8, which is the mode of this given distribution. So, now students, we are going to find out mean also. we have the class intervals. So, I have opted to calculate mean using assumed mean method. You can do this question using other methods also, like step deviation method. So, let us do this by assumed mean method. In that case, I will first calculate xi. Remember, that was the class mark of each class interval, that is the mid value. So, when I calculate xi for first class interval, it is 10. You can see 10 lies between 5 and 15. And what was the formula? Upper limit plus lower limit upon 2. For second class interval, it is 20. So, calculating all the xi's, I can now take my assumed mean. What was assumed mean? Assumed mean was the middle value of xi, that is the xi lying in the center. But I can see there are two values of xi's lying in the center. So, you can take any of the two. It does not matter which value out of these two you are taking as assumed mean. In my case, I will prefer to take 30 as assumed mean. So, I will do my calculations of di taking a as 30. So, di was xi minus a. It will be xi minus 30. For each xi, I will calculate it. So, 10 minus 30 will give me minus 20. And 20 minus 30 will give me minus 10 and so on. After calculating di, I will multiply di with fi. So, this di will be multiplied by fi. 6 into minus 20 gives me the answer minus 120. Similarly, 11 into minus 10 gives me the answer minus 110. 23 and 10, 20 into 0, I can multiply them and write it. Now, again I have some negative values and some positive values. I am going to add these negatives separately. Minus 120 minus 110 gives me answer minus 230. When positive values are added, I get 230 plus 280 plus 150 as answer will be 660. So, when I solve these two numbers, minus 230 plus 660 gives me answer as 430. This is my sigma fi di. The formula of mean was a plus sigma fi di upon sigma fi. Then substituting the values, in place of a I put 30, in place of sigma fi di I got 430. Sigma fi, that was the sum of fi's, is 80. After substituting value and calculating, I get the mean as 35.37 years. So, now we are going to interpret these two measures of central tendency which we have calculated in this question. The first was mode. The value of mode we got was 36.8 years. The meaning is that the age of maximum number of patients admitted in the hospital was 36.8 years. The value of mean we got was 35.37 years. The meaning is that the average, on an average, the age of a patient admitted to the hospital was 35.37 years. Now students, let us solve the same question with some difference. I have changed the class intervals. The class intervals previously were 5 to 15, 15 to 25, 25 to 35 and so on. But in this case, I have taken the class intervals as 5 to 14, 15 to 24, 25 to 34 and so on. Can you see the difference? Yes, the difference is in the upper class limit. In this case, the upper class limit of class interval is included in that interval. So, 14 is included in first class interval. To solve such a question, that is to find out mode in this case, we have to make these class intervals continuous. Let us see how. To solve this question, first I have to make few changes in the class interval. I have to make these class intervals continuous. How to do it? I will take upper limit of first class interval and lower limit of second class interval and find the difference. What is the difference between 15 and 14? It is 1. Now I am going to take half of it. What is half of 1? It is 0.5. So, to make these class interval continuous, I will subtract 0.5 which I got taking half of 1 from lower class limit, that is 5 minus 0.5. So, it will be 4.5 and I am going to add 0.5 in upper class limit, that is in 14. So, I get 14 plus 14.5. For second class interval, again I am going to do the same. 0.5 will be subtracted from lower class limit and 0.5 will be added in upper class limit, getting the class interval as 14.5 to 24.5. For third class interval, 0.5 will be subtracted from 25 to get 24.5. 0.5 will be added in upper class limit 34 to get 34.5. Now you can see that our class intervals have become continuous. 4.5 to 14.5, then 14.5 to 24.5, 24.5 to 34.5 and so on. Now the process remains the same to find out the mode as we have done previously. Again we are going to see the greatest frequency, the highest frequency. So, the biggest number here is 23. So, highest frequency 23, this is going to serve as our model class. So, the class interval we are going to consider now will be 34.5 to 44.5. Let us come to the formula. Our formula for mode was L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Here you can see the value of L will be different from what we have taken in our previous question. So, in this case value of L, that is lower limit of model class, will be 34.5. So, L will be 34.5 plus rest of the values are actually going to be the same. So, F1 will be 23, this one, and this is F0, this is F2. We are going to substitute these values and you remember what was H? H was class size, that is upper class limit minus lower class limit, which turns out to be 10 in this case again. So, H will be 10. After calculation, as I told you before also, first multiply this and solve it separately and then solve 46 minus 35 to get 11. We got the same number 20 by 11 as we got previously, but what has changed? The value change is L, that is now it is 34.5. So, the value of mode will change accordingly. Now, we get 34.5 plus 1.81, which is decimal representation of 20 by 11. The sum turns out to be 36.31 years. You can see the mode in this case. Now, students, do this assignment for your practice. The first question is, you need to explain what you understand from mode. Question number 2 is that this data gives you information on the observed lifetime in hours of 225 electrical components. You have to find out modal lifetime for these components. In question number 3, This distribution gives you number of runs scored by some top batsmen of the world in one-day international cricket matches. You need to find out mode for this data. You can see that class intervals are given and frequencies are given. Do try these questions. So, in this session, what we learned? We understood what do we mean by mode and also how to calculate mode in different representation of data. Here, we use the formula for mode as L plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H, where the symbols mean as L is the lower limit of model class interval. Model class we found by taking the class interval where the frequency was maximum. F1 was the frequency of model class. H was class size upper limit minus lower limit. F0 was the frequency of class preceding to model class. F2 was the frequency of class succeeding the model class. So, you can apply this formula and find the mode. Students, I hope you have understood the concept of mode in this session. Thank you so much.